Hello, everyone. Happy Friday, and welcome to our Live with Labs session on mobility security. It's going to be a great session. Seriously, I'm so excited for this one, y'all. But before we get started, I have just a few things that I want to go over with all of you. The first being our chat. So the chat pod is open. Feel free to get in there, introduce yourself, have some conversation. We just ask that you do keep it relevant to the information being presented and keep it professional. Second off, this meeting is being recorded. So if you don't feel comfortable being a part of the recording, now is a good time to go ahead and drop, and you can always view the recording later. And then last, we have our Q&A pod. So I know y'all are probably going to have a ton of questions. So I just want to encourage y'all to use that Q&A pod throughout the presentation to submit your questions for our speakers, which I'm super excited to introduce. Today we have Helbongo and Eamon. These are some experts here at AT&T to help us all learn about mobility security. It's going to be a great time. So with that, Helbongo, if you are ready, I can go ahead and hand it over to you.
Thank you, Ashley. Quick voice check. Can you hear me clearly?
We sure can.
Okay, very good. All right. Hello, I'm Helbongo Mara Gamata here at AT&T. I'm a principal member of technical staff. What I do is I introduce new technologies. I support the machine that allows you to make voice calls on your cell phone. And recently I took over responsibilities in the security organization. So I also scan all the software that goes on our machines to keep our network safe. Okay, I've been doing this for 23 years now, and it's fun. All right, today I will be, thank you, Ashley. Today I will be going over some security concepts relating to the cloud and to the VoLTE, and basically on a mobility network. And since we don't have a lot of time, I try to stay very much high level and to just give you an introduction. And I will be happy to take any questions you have and address that. Okay, let's go to the next slide, please. So I start with what is cloud computing. I'm sure you heard a lot about cloud, but what is it? Right? So cloud allows the delivery of computing services like server, storage, database, and networking, all of that over the internet. You probably use Gmail. If you have a Gmail account, you're using the cloud, owned by Google. Okay. Google owns the servers, Google owns the application, the Gmail application. You just sign up and start using it. Okay. Now, business also like to use cloud because there is an advantage to cloud, right? They can save money. They don't have to worry about the hardware, right? And in most cases, they don't have to worry about supporting the infrastructure, right? And the good thing with the cloud is you only pay for the service that you use. And if you need more servers, the cloud provider will take care of that. You will not have to worry about the hardware needs. Okay. Next slide, please. Okay. There are three types of clouds out there. So you have the public clouds, private clouds, and hybrid clouds. What is a public cloud? Public cloud is, again, an example of Amazon or Google or IBM, and recently even Microsoft. So the public cloud is the cloud owner owns all the hardware, the application. Like a perfect example again is the Gmail. Right? You don't pay for. In our case, we don't pay for it, but Google owns the servers and the application that runs the email. Okay. The next example is a private cloud. And a private cloud is a company can decide to own the hardware and the application and everything that runs on the cloud, and only allowed people from that organization to use it. I take an example, AT&T. AT&T have their own cloud. Only people that work for AT&T can access the cloud, and only AT&T manages the cloud, right? That's the example of the private cloud. You can look at Amazon as a private cloud for applications that only Amazon uses. Okay, hybrid cloud is not the third example of the cloud type. In the hybrid cloud, you have the cloud provider could own the servers, and you can come with your application and run them on that server. So I take an example. If you are a student, let's say you go to University of, just an example, University of Notre Dame. Your email, for example, is run and managed by your university, but also using cloud on Gmail, for example. Like your address, your email address will say johndoe@notredame.edu, but you use Gmail to access your email account on the university. So what that means that your university is just running all their infrastructure, the IT infrastructure on the cloud that belongs to Google. Okay. Next slide, please. All right. Now that you have a little idea of what the cloud is, you understand now that all the data is transferred over the internet, right, on the cloud, and the cloud can be accessed from anywhere, right? You can be in France, in Argentina, or in California. You can always access your email account, for example. But because of that, we need to make sure that the data is protected, right? So we need to come up with a mechanism to isolate the data and protect it from direct access. Also, we need that data to be not to be altered or modified. Okay. Next slide, please. All right. So how do you protect the data? We have to come up with countermeasures. First, access control. We don't want just anybody to access the data. So we implement access control, means with different privileges. Who can access the data? At what level can you access the data? And what can you do with the data on the cloud? Second, auditing. We want to know who is accessing the servers and what they're doing. And third, we have authentication. So before you can even access the data, you need to prove that you are who you say you are, right? Even if you have an account on the server, you still have to authenticate. And last, authorization. Once you authenticate, we want to say, okay, are you authorized to access this type of data or different type of data? For example, if you're an engineer, you might not be authorized to access financial data, for example, right? Or you cannot access human resource data, for example. Okay, next slide, please. So here in this slide, I try to demonstrate how you can, how do we access data on the cloud, right? So let's say you are the client and you want to access data that is on the cloud storage at the very bottom of the picture here. So you cannot just connect directly to the server. One, if you alter the data, then the whole data is, the whole database is will be corrupted. So what we do, we actually put a copy of the data on the broker, and we configure the proxy as like an intermediate, right? So what the client requests data, the request comes to the proxy. Proxy is configured with policies to make sure that the person is authorized to access the system. And then you have access to the broker, which have an image of what the data you are requesting. The broker will request that data from the cloud storage. And then data flows back to the proxy and then goes back to the client. And the reason we're doing that again is for data integrity, so that even if you modify the data, you cannot modify directly on the storage. It goes through the broker first, and then it goes to the cloud storage. All that is to protect the data. Okay. Next slide. Okay, another countermeasure is encryption. It's good to have the data stored in a secure place. But while the data is being transmitted between the client and the server, we want to make sure that data is protected. So if somebody happens to intercept the data, they still won't not know what to do with the data. That's why we encrypt it. Encryption will assure that if the data is intercepted, it will be very hard to read it. Almost, I wouldn't say impossible, but very, very hard to decode it. Okay. Another countermeasure is physical access. It's good to have all the algorithms. It's good to have all those firewalls to protect your network. But if anybody can have a physical access to your network, that poses a problem, because somebody can go into your server room and just take the hard drive away, and you're going to lose your data. So for that, all the physical infrastructure of the network must be in a room that is secure, and access is only authorized, is only allowed to authorized personnel. Okay. Thank you. Now, before I jump to VoLTE, any question regarding the cloud? And
a question did come in asking, what does the broker do?
Okay, so the broker gets a copy of the data that you're requesting. But that if you alter that data, you only alter it on the broker. You do not alter the data on the database. So we can still have the database, the data on the database to be still intact.
Great, thank you.
Okay. Good question. Now let's talk about VoLTE. Okay, before we get to VoLTE, I'm going to give you a little bit of a history of VoLTE. So first there was LTE, which is a long-term evolution. And LTE evolved from 3G, which came after 2G. If you remember last week, a presenter gave you a short background about 1G, 2G, 3G, 4G, and now 5G. Okay, so LTE came right after 3G. And LTE depended on IMS to deliver voice call, which IMS, which is an IP multimedia subsystem, which is an all IP network. Okay, and after that, LTE could not, does not support the voice call, right? So, and SMS. So what did the service providers do? They use it. We introduced a new technology called CS fallback, which is a circuit switch fallback, and SRVCC, single radio voice call continuity. Those two technologies were introduced to allow voice over LTE. I mean, to allow LTE to carry voice over IMS. And then came VoLTE. We realized that with VoLTE, the technology will allow the transmission of voice over LTE. Okay. Next slide, please. So here I'm showing you a picture of where VoLTE sits compared to IMS and GSM. And actually GSM is the two, I meant GSM and UMTS, right? 2G and 3G. So if you make a call from the first 4G compatible phone to another 4G compatible phone, your call goes VoLTE to VoLTE. So both phones are on the VoLTE network. You still have to go through IMS for your voice call. And if you making a call, if you're calling a non-VoLTE subscriber, your call goes from VoLTE to IMS and then to your legacy 2G, 3G network. Okay, next slide, please. Okay, here I am showing you a general table of what the threats are, how do you respond to the threat, and security management, how you keep up with the threats, with the security in the whole. So if I take an example of the first one, threat to data, right? Your data goes under a lot of threats. What do? You have to come up with countermeasures, for example. The security of the data storage, security of the data during transmission, and once you're done with the data, you make sure that you can destroy the data, but in a secure way so that people don't have access to your old data. And in security management, you have to have a system in place that we can always review and evaluate your countermeasures and evaluate the new threats so that you can respond in a timely manner. Okay, and I will go into in a detail, but this is just a summary of what I will be talking about in the next slide. Next slide, please. Okay, so VoLTE, like any IP network, is subject to various security threats and vulnerabilities. Right? People out there are looking to eavesdrop, listen to your conversations, or in some cases, steal the data, and in some cases, just trying to paralyze your network with fraud attacks and so on. Okay, so threats to the applications. Let's go back here. So there are two threats here. You have threats to the application and threat to the infrastructure. So what is a threat to the applications? It's a threat to the signaling. Signaling is what happens when you want to call a friend. You punch in the numbers and you hit send. Your phone talks to the network and makes sure I'll allocate all the resources before you can even say hello. So that's signaling, and that signaling could be is also under threat. Right? It's people with people can compromise the signaling and paralyze your network. Voice media and other applications for VoLTE are also under threats, right? Your voice is, somebody can intercept the voice call, for example, because once it goes onto VoLTE, it becomes IP traffic, right? So it could be intercepted. And threat to the infrastructure is your hardware and your software. If your software does not have the current patches, if there's a hole in your software, hackers or malicious activity, people with malicious intent could take advantage of that, and in some cases just bring your network to a halt. Okay, next slide, please. So because of all those threats, we have to come up with countermeasures. You have to secure your network and secure your data. So let's start with data. Okay, so just like on the clouds infrastructure, the data on the VoLTE network should be secure and protected. So the machine that routes your calls, for example, have routing algorithm and have routing data. That is, if it is compromised, your machine will not know how to route the call. So people won't be able to make calls. So we need to protect that. Access to that server is protected with authentication and access control. So even if you access the data, you need a specific privilege to modify anything on the system. Okay, another thing is data backup. We need to always back up your data in case something happened to your data. You can always reload the valid version real quick, because the longer you take, the longer you will affect service for your subscribers. Transmitted data, again, must be encrypted. Otherwise, if the data is intercepted, it could be, they can steal a copy of it. So you need to encrypt it like that. Even if somebody's intercepted data, they would not know what to do with it. And just like with the cloud, physical access is also very important, right? Like I said before, you need to secure your servers. Only authorized personnel should be allowed in that room, right? We don't want somebody to just walk in and plug in a device and then download your data, right? Next slide, please. Signaling. So your signaling, like I said before, signaling is the message that allows the phone to connect to the network and allocates the resource for you to be able to speak with who you're calling. So the signaling, how do you protect signaling? Then one technique is to detect the length of your packets, because when you configure your network, you specify the size of the packets that goes through your signaling protocol. And if you see that the packets are are longer than what you are specified, you can suspect something is somebody is doing something on your network, so you can take appropriate action. Another technique is also to detect self-loop. Self-loop is when the server is running a loop to detect configuration net connectivity on its own interface. Normally, people will only run that while they are troubleshooting. Now, if its request is coming from outside for a self-loop, you know that's not right, so you can take appropriate action. And another technique is to limit the rate of requests per single user, because to prevent the denial of service attacks, right? Because if the same request is coming from the same user coming multiple times, it would allow people to overload your server. Okay. Next is the network. How do we protect the network? Okay. So we can deploy security protective devices like firewalls. And again, anti-distributed denial of service is a system mechanism that even if one server is under attack, you cannot replicate that to all of the other servers. Okay, and we can have intrusion detection systems to monitor any malicious activities and detect them. Okay, next slide, please. Another, now this is area of security that I am directly involved with is software vulnerability. So just like on the cloud and on VoLTE, any software that goes on the servers, we need to scan it check for known vulnerability, see if there are any holes. We request a patch, so the vendor can provide a patch to fix that, right? If you have, for example, nowadays we know Telnet is a protocol that is not secure, so we make sure that Telnet is not allowed on the software, for example. And then another thing is we want to reduce the surface attack using plug and play. PNP means plug and play. So we want to make sure, for example, USB port on the server, you don't want to allow anybody to just be able to plug in a flash drive on a USB and then download the data. So we disable that, okay? Again, if we run the software and we detect vulnerabilities like that, we go through mitigation, which means we have this vendor go back and patch the software. Okay. Next slide, please. All right. Q&A.
All right.
And
I'll just before we tackle the Q&A, Helbongo, if you give me just 1 second, I'd like maybe to add one more thing regarding the security and how critical it is for everyone on the call. Right? So I think a lot of a few guys really, you're student, you're studying potentially engineering, computer science, and so on. And one thing that we want you to really remember and take out of this presentation is that security is extremely critical, but it's also everyone's responsibility. Regardless what you do, whether you're a web developer, whether you're a solution architect, even if you're a sales engineer, you want to distinguish yourself by always thinking security. If you're a web developer, you might be working on a libcurl to do some OpenSSL connection and so on. And you have to be able to think that there is some version that have certain vulnerabilities, some version that address and fix those vulnerabilities. And you might also want to build your own libraries because there are security issues with some libraries that are available openly and widely. And if you're an architect, you might be thinking to add a firewall, to add a proxy, to add a broker, and so on. If you're a salesperson, you will have to have some component to maybe identify the security performance of one of the solutions that you're either selling or building, and so on. So security, whether it is at AT&T or anywhere else, is extremely important. It is something that you have to think of every day. Right? So when you go to the office, you have to think security, whatever you are doing. So that's extremely critically important. And as you see the job market in the future, you will see that it's something that will continue to be highly in demand. So I certainly advise you to read about security in the future, and the more you know, the better it is. And as you get into your professional career, always think security, and that will give you an edge because you'll be able to distinguish yourself and add value to your company and maybe even open a company within the security side of the house. So that's the one little thing I wanted to add on the security. So now we can go through the Q&A. I'll touch one question, and then Helbongo, you can go through that. Just regarding VoLTE and voice over IP. So VoLTE, ultimately, it uses 4G, right? So you need LTE to do VoLTE. You can do voice over IP over 3G or 2G. And you'll see a lot of differences in terms of reliability, quality of service, where VoLTE guaranteed that quality of service that give you that reliability, and voice over IP doesn't. And that's one of the reasons you see all kind of company have voice over IP solution, because you don't necessarily need to guarantee that quality of service. You can just have any internet connection and have and build your own voice over IP solution on. Again, VoLTE, leverage LTE, it is inherently part of the LTE standard. Right, so there is an entire architecture, that has been optimized to provide you that quality of service.
Correct. That's a good point, Amen. If you go, VoLTE guarantee quality of service and security, and it's a well-managed network compared to the voice over IP, which is best effort delivery, and you don't know what. You have no control over the delays, for example, right? So that's a good point. And like you said, security is everybody's responsibility. It's not just the IT. That's true.
There's a very interesting question that I would like to address. It's from Sonia. It's something that we have seen on the past presentation as well. And I think it's something that is probably at heart and critical for everyone. So the question is, how is the cloud computing industry affected by COVID-19 pandemic? Is there any effect at all? So there is, but it is actually a positive effect. So COVID-19 ultimately, what it really did, it brought us into the future, right? So it made the future happen today. So all you see right now in terms of the usage of cloud solution, right? Because we're all working from home, right? We're all studying from home. We are today on this webinar on Zoom, right? So COVID-19 had a positive impact on Zoom. Zoom obviously will have an architecture that leverage some cloud instances because it is a little bit cheaper to use the resources as you have these calls. So COVID-19 pushed us into the future. So there is a massive impact on cloud computing because it made cloud computing at the core of what we are doing. So companies that have solutions that leverage the cloud, obviously we've seen them gain value. Right, so that's the impact that COVID-19 had on cloud computing in general. And where we see today, this probably wouldn't have happened for at least another 5 years. Right, so we're 5 years into the future, and maybe even 10 years because of COVID-19 and the way we're using cloud computing and the way we're working from home, studying from home, and you can see that in the industry.
Correct, and I would like to add one thing to that is. How COVID-19 really brought to light the need for network security. And a perfect example is Zoom, because Zoom recently updated their application with to support more secure, to make it more secure, right? Because before COVID, Zoom was just come and use it, but now they add more security into it because more and more people are using Zoom because of the COVID-19. Right? And another effect is, yes, COVID-19 has a big effect on the computing world because now everybody is turning into the computer, to the network. So it puts a stress on the network, whether it's a mobile or not. So yes. I think one thing COVID-19 do is force people to use more computers. Yes.
Yeah. There's a question. I'll answer the question very in a generical term here, and ultimately the question is from Kian. So it's going to be a very generic answer. In the realm of security, right? So there's always the assessment of vectors of vulnerability, and we don't only look at one vector. We always look at multiple vectors. So you have to think, and if you remember, there was a slide that Hilbongo was showing. You have to think of the physical access. You have to think of the network access. You have to think of the software level. So it isn't only one vector. But we don't want you to think of only one view or one vector, or is it only one person that might be hacking? There are multiple ways to access information. You have to be able to think of all those multiple ways. Right? Security isn't only about having a person with a laptop connecting into a network. There's all kind of vector. You have the physical vector. Right? It could be gaining access to a site. It could be remotely gaining access. So when you think security, you have to think of all those vector vulnerability. So am I protected by someone tampering with a device, right? Physically, am I protected by having someone who isn't supposed to access to my network, right? Am I protecting myself in terms of access? So these are the people that are allowed to access the network. Now these people may want to do X, Y, Z. Am I protecting against that? Am I protecting from mistakes, right? Because there is also some mistakes that are happening. Am I protecting against identified vulnerability? So you will see that, I mean, the government industry, there's multiple consortium. What they're doing, in essence, they're constantly looking for vulnerability because there's a lot of software that is being used, that is being developed. There's open source software. and you have to constantly assess those pieces of software, and you have to continually upgrade them and bring them to a revision that address those vulnerability. So if I can answer your question, is really there's multiple vector, and you have to think of all those vectors.
One thing I have to add is security is not just, the threat is not only coming from outside, the threat could be coming from inside too. So when you have your network, you have to make sure it's protected internally also. You have to take measures to protect it also from the inside.
Okay, now I'll touch really kind of a little question from Ola Sombakni. It's really kind of more of the cloud. And there's a question regarding the differentiation between cloud delivery. So infrastructure as a service, platform as a service, software as a service, and so on. So I won't touch the other part of the question because it's a little bit unrelated to what we're doing in general. But regarding IaaS, PaaS, and SaaS, right? So infrastructure, platform, software, right? So software as a service, the easiest one, and Bongo gave it earlier on, was really Gmail, right? So your web mail, in essence, the web mail, the web servers are all running on a cloud. You are not installing, for example, a mail client. So you guys are probably much, much younger than us. And there was a time where if we wanted to access our mail, we actually had to install software on our PC. Maybe we didn't have any laptop. We had to install pieces of software, and then we had to configure that software to talk to a server that is running somewhere, right? And then we would be able to on-demand retrieve email as we were establishing our internet connection. So we had that physical laptop that we had here, and there was a physical server somewhere where our mail server was running. That is gone, right? So that would have been a physical solution. Now with software as a service, for example, or mail as a service in a certain way, right? Where your mail is running on the cloud, you're just opening a web browser, your mail client is in essence running remotely, right? It is part of your web browser, and all the services are running within a cloud, and you don't really care which server it is running on and so on. And in the case of Gmail, Google take care of that. Another example of software as a service, maybe Microsoft with Office 365, right? So you don't need now to install Word or PowerPoint presentation on your laptop, right? You can just from your device or from anywhere, just access your documents that are saved on some sort of cloud and run the application in the cloud, and without saving into a USB stick and so on. So that's kind of like software as a service. Now, a platform as a service and infrastructure as a service. Infrastructure as a service is a little bit more tricky. So the infrastructure as a service could be something where we're working on right now, where we're actually building an entire mobility network that has the capability to run in the cloud, right? So now see it where you have a function X, Y, Z, maybe to make a VoLTE call. Now you would have an infrastructure that provide the capability to run that call on the cloud. So that would be kind of the way you would describe infrastructure as a service. So hopefully that answers your question regarding that one.
Do you have another question?
Yeah, there's a few more questions. There's actually very interesting questions. There's some questions, by the way, guys, that are absolutely brilliant, and we're not necessarily in a good position to provide you an answer, but it's something that we can provide some feedback in the future and see if we can have a presenter bring you that. So, for example, Desmond has a really good question regarding quantum computing and the type of encryption, the type of security that you can gain out of quantum computing. I am certainly not in a position to answer that question properly, so I will not answer that question, but it's a great question. And it's something that we will take the feedback on these type of things and see the type of presenter that we can have to address those questions. But it's a great question. I can answer Savayata question regarding the broker to the cloud service provider. So see it this way, right? The broker really, or in a cloud security environment, it is basically a server, right, or a box. You can even see that you may be running in premises to kind of So it's a good question because it's not easy to explain it properly. So in essence, you will maybe filter. You will look at packets, right? You'll do packet inspection. You're not really a firewall, but you can look at packet inspection, or you can look at the type of authorization, and you gain some information about it. So that's kind of like what the broker is. So it's something where it's not really a firewall, it's not really a proxy, but it kind of gives you a little bit of that. But ultimately, the whole purpose is to ensure that you're accessing your cloud services and your cloud function, and that access to those cloud services and that cloud function is appropriate. And then on top of that, the broker has kind of some intelligence into it, where it inspects some of the ongoing requests that you may have, and identify whether those requests are erroneous or not. Right? Obviously, the proxy doesn't do that. There's some firewall that has some of that intelligence, but not really purposely for accessing a service necessarily and querying that particular service. So that's how I can explain that question.
Okay. I see a quick question here from Akshay. What are the different steps taken in short and long duration in case of security breach in the VoLTE? Again, that depends on the attacks, right? It depends on what happened. If it is just one server that was compromised, there's always a backup server. We can isolate that server that is being compromised, and then the backup server can kick in and continue providing service. Again, the duration will depend on how serious the attack was. Right? If the attack was detected right when somebody has an authorized access, we can easily remediate with that. But if the attack took last long and the damage was big, then yes, it will take longer. And sometimes you can even if it take you a long time to detect the attack, it will also take you a long time to fix it also. So it really depends on what the damage was done.
There's an interesting question from Titus, and I'll try to answer and add some perspective into that question. So Titus has a question regarding the migration of data. Favor forward migration, meaning moving to a cloud is much easier and less complication. And how tactful is it to move from cloud-based system back to in-house infrastructure? So it is a great question because in essence, what Titus is in essence saying is, hey, I might be having a local infrastructure today, and I may want to move it tomorrow into a cloud. And then eventually, maybe it makes sense to move that from cloud to an infrastructure that I own. So I'll first answer your question in a very generic way, Titus, and in a way that I think is very useful for everyone here. So the capability to move data from cloud to cloud, right? So if I'm running a service, for example, I have Ayman Mail running right now, right? And maybe I'm using Amazon Cloud. And maybe Amazon is too expensive, I'm going to go to Google. Or maybe now I'm on Google, but Amazon is more performing, I'll go to Amazon. Or maybe Microsoft bring different quality and so on. So the capability to move from one cloud to another in an easy manner, it's something where right now there's a lot of energy in the industry, right? There's a lot of company, there's a lot of consulting company, there's something that all companies, including AT&T, we're all working on understanding how to do that in a more efficient way, because it gives you a competitive advantage. And there's some big company that even have solution to move from one cloud to another and kind of monitor and orchestrate your entirety of your services in different clouds. So that's one aspect of your question that I wanted to highlight. It is super critical. By all means, expertise in that domain is hard to find, because it's something that is happening right now. It's something that we're realizing more and more. So while your question is from cloud to non-cloud, I want to really ensure that everyone understands that moving from cloud A to cloud B is extremely critical. And if you understand how to move your service and your software from cloud A to cloud B in an efficient manner, that is brilliant. So you might be using some load balancing where half of your requests are going to one cloud versus the other cloud and so on. And eventually you turn off services from the older cloud and you bring those services up into the newer cloud. So there's that is important. Now, regarding moving back to an in-house infrastructure, it is also possible, but that's the same type of decision that you will be making, right? If your application are cloud native, right, it is very easy to also have your own private cloud and actually move that data from a cloud-based system somewhere to an in-house based system. Now, for some application, and this is something that I can't really think of any application right now that is running on the cloud that you want to have on a non-cloud infrastructure. So in terms of the performance gain and so on, and the cost perspective, I can't think of anything. Right? So I don't see a business justification or an application right now that I would say, you know what, I'm no longer using cloud here. I'm going to go to an in-house infrastructure. I can certainly think of moving to a private cloud infrastructure, but I can't really think going from a cloud solution to a non-cloud solution in terms of the application that are currently having today. Right? So it might happen in the future, but right now there's nothing I can think of.
There's another question I would like to address. Yes, it's from an attendee. What is a hole in the application exactly? So a hole is, I would say a door. For example, I just keep a door that allowed a hacker to access your network. I take a quick example is like Telnet. Telnet allows you to remotely access a server, for example, right? Telnet use port 23. Recently, security discovered that Telnet is not secure. The reason is not secure is somebody can listen to that port 23 and capture your authentication data, given your user ID and your password. And the person can use that to access the network, and then from there, do malicious activities. So that's one example of a hole on the network. So how do you remediate with that? We just disable Telnet from your server. You use SSH instead, which is the secure shellnet application.
There's a question that I'll touch on. The question is from Musharat, and it's something that also we've seen similar question in our past presentation, and I'm assuming we'll see similar question in the future as well. And the question is regarding the courses and certifications that are needed for cloud security job and solution architect job. So I think it's a good question. We understand that you certainly have concern on what type of certification you may want and so on. And if you want to work in security, or if you work in solution architecture. So obviously all the big players have certification, and all the big, when I say big players, I'm talking the big cloud company that we're accustomed to here on the news, right? So they all have certification for their cloud software. Right? Most big or networking in the past, you had the Cisco certification. Right now, Azure has certification, Google Cloud has certification, Amazon has certification. So certainly, and I'll answer that the same way I answered it previously, if you have a certification, really what you're telling your potential employer, right? So if I'm working for a company that work on all clouds, right, and they're looking for someone who understands cloud, and let's say I have a certification with Azure, I have a certification with Amazon, and I have one with Google. Now that potential employer, they will see me and will say, you know what, this guy at the release knows the basic. Right? So by no means it means that I am an expert, or at the very least, I have that capability to have those conversations. Right? So when I see someone who has those certifications, in essence, what I'm telling myself is, okay, that person has the basic, right? So I don't need to spend time on the basic. Let me see how that person thinks. So in essence, that's what you're doing. So if you're looking for positions that are cloud centric, it is extremely helpful to have those certifications. And it's also very helpful to show that you have initiative, that you played around with cloud on your side. Maybe you're running services on the cloud. Maybe you have a website that you tested on Cloud X, and now you're testing it on Cloud Y. So that's kind of how you distinguish yourself, is showing that you're using. Obviously, the certification are always a positive, right? Because you in essence, you filter yourself positively into being seen as a potential employee. And in terms of security, there is different. All the companies that I mentioned, they also have security component, right? So there is identity authentication management certification. Generally speaking, they're a little bit more advanced certification, but they do exist. So all companies that are on the IAM space have certificate as well. I'm not too familiar with them, so I can't really give you an answer on how useful or not they are, but I would suspect the same rule apply, right? If you have those certificates, it's always a bonus.
Good. Oh, I see an interesting question here from Titis Ogunemi. What's your thought on the issues of security surrounding elections over the internet?
Yeah, Helbongo, if I may interject, it's a tough question, and I'm not sure how much we can be honest with that question, because it's a really difficult question to answer. There's too many components to it.
Right.
Yeah.
If
you want to add a little bit of perspective, but yeah, very like, this is purely personal opinion. Yeah. This is too complex to even address or assess. So.
Now, I was going to say, all this, the big issue is data integrity, right? It's just you have to make sure that the results are not temporary. And that's the biggest issue. How do you keep it secure? But like Eamon says, it's a big topic. So if I had to resume it in one word, I would say data integrity.
Yeah, so the one thing, I mean, we don't really want to touch on that question, Titus, and it's a great question, and I commend you for asking it. And it's normal to have concerns on security, but it's actually great for you guys to have concern on security, because it means that you potentially have the capability to find solutions. So we want you to maybe concentrate on that. You guys really, in essence, you're young, you have that energy, you're coming with a new perspective, and you're seeing things, and if something you see where there's an opportunity and so on, by all means, we certainly advise you to work and seek creating companies or something where you have perspective on helping company X, Y, Z, and so on. Those ideas are good, and we encourage you to have them. And it will certainly, if you think of security, that's great. It's just one application, but there's many more applications. There's a lot of quantum computing questions. I wish I was really more knowledgeable in that field to answer those questions. They're great. Great question. We'll try to see what we can do maybe in the future. But it's great to see that there's a question there.
Oh, I see an interesting one here is, but does VoLTE really save phone battery compared to LTE? I would say phone battery really, it depends on a lot. It depends on the application you're running on your phone, depends on your coverage. If you're in an area where the signal is very weak, the battery, the phone will work harder to try to look for another signal, another cell, and in this process, it will drain the battery. So I wouldn't say that, I wouldn't measure the phone battery based on the VoLTE or LTE, which they use the same radio anyway. So I would base the phone usage on the application that's running on the phone.
There's an interesting question. I'll answer that question from Gabriella. So the question is, with more people using and getting the opportunity to use cloud services, how does the demand for speed factor in? With 5G being put into more places, the increase in demand for faster download, how does that affect VoLTE in any ways? So it's a good question. And when we're talking about mobility in general, right? So there's like first generation mobility, second generation mobility, third generation mobility, fourth generation mobility, and now we have 5th generation mobility. Each of those if I may use, generation of mobility or new set of innovation, of new paradigm of innovation, is always based on some sort of technological advancement. So for example, on the 4G side of the house, really the IP networking is a key component that enabled 4G. Now on the 5G side of the house, a key technology that is enabled 5G is actually cloud computing. So cloud computing allows us to enable 5G. So if you guys remember last week's presentation that we had with Vikram, so one of the way you can describe 5G is latency. So the problem that 5G tackle is a latency issue, right? So we'll go from the beginning, right? So first G, let's connect people, right? 2G, let's bring some services to people, right? So first generation, we just want to make a call over the air, right? Second generation, now let's add a little bit of services, maybe some SMS, right? Now I'll be able to text people over the internet, over a mobility network. Maybe now I want to have some basic data and basic browsing or email via my mobility network. So that's 2G, right? So now we connected people. Now we add some services. Now on the 3G side of the house, I want to bring some data as well, right? So this is like kind of where the iPhone came up in 2007, and all of a sudden people want some data, right? Now 4G is, hey, I want a lot of data, right? So now like I have a lot of smartphones, I have a lot of smart application. I want to have an internet type of set of devices that are constantly connected, and I want to be able to see video and so on. So now I'm bringing the massive data side of the house, right? So this is where like we're talking about bandwidth. Now 5G come into the picture, it's a little bit different. 5G, we want to connect millions and billions and billions and billions of devices, and we want those devices to interact with each other. Right? So this is kind of like how you think of those generations. Now, every time you think of that, there is technology that are associated to it. Right? On the 5G side of the house, cloud computing. Cloud computing is what enables you to reduce the latency. Now, when we're talking about how 5G comes out into mind and how I can use cloud, I can move things to what we call the edge. Right? So let's say here, we'll take really basic example where I'm just basically doing a ping, right? So I'm basically querying a server. Right? So if I'm querying a server and the server is running in my living room, and I have a cable that is connected from my laptop right now to my living room, I'm going to get an immediate response, right? So the latency is awesome, right? Because it's such a proximity. Now, again, this is not a realistic example, but let's say that server now is in China and I have some sort of cable, maybe that, let's say I don't have any loss, but I keep the same speed that I have today. But let's say I have a cable from my laptop to that server in China and it's just a long cable. Not a realistic example. But now the latency is not going to be good, right? It's going to take so much time for me to be able to query that thing and then bring it here, right? So what I'm trying to illustrate by this example is if I have the capability to move things closer to a consumer, I can reduce latency. Now, the way you think on the 5G side of the house, you're basically looking at your mobility network here. There's signaling stuff, right? So maybe if I want to improve signaling, rather than having my signaling, and you remember, Bango was talking about that a little bit on the VoLTE side of the house, right? On how signaling is important and so on. So rather than having the signaling done, let's say, on a data center that is national, so maybe I have something a little bit far away from me, if I can bring some of those functions closer to the user, all of a sudden I'm reducing the latency. Now, how cloud computing is used on the 5G side of the house is you actually have the understanding to create services close to the user and services away from the user. And then you have the ability to move services from one location to another. And then you have the ability to increase the number of, maybe the number of compute that you have and so on, right? So that's how you reduce the latency. That's how you leverage cloud for 5G network. So hopefully that answers your question, Gabriela.
Great. And y'all, I'm sorry to cut it short, but I think that's all the time we have for these questions. I know we have a few left, so I'm sorry if you weren't able to get your question answered, but we will be sending out a link to this recording so that you guys can watch it again. Feel free to reach out to our AT&T College Recruiting mailbox with any questions, and we can make sure to get that over to our amazing labs team. Make sure to join us next week. We will be back same time, same place, talking about the introduction to automation tools. So really exciting presentation. We'll talk about automation, open source technologies, and really how it applies to a large ecosystem in the mobility environment. So that is going to be a great presentation. Not sure it can top this, but we'll see. Thank you, Hilbongo and Eamon, for your time and your expertise. We greatly appreciate it. You guys, there will be a survey at the end of this. Feel free to give your candid feedback so that we can take those action items and make changes if necessary. So we appreciate y'all's time. Y'all have a great weekend, and we will see y'all next Friday. All right. Thank you, guys.
Thank you.